to today's session. We're delighted to have with us Dr. David Connolly. David is currently, and stand corrected if I'm wrong, David, CEO of the Irish Wind Energy Association. And we really look forward to this presentation. I'll keep an eye on the chat for questions. David's going to present for about 40 minutes or so, and then we'll open it up for a Q&A for the last 10-15 minutes. Over to you, David. Thanks a million.
Yeah, thanks very much, Cormac. Sure, I'll just throw up the slides here and hopefully the IT gremlins don't uh, do any funny tricks and everyone can see that, hopefully. So hopefully you can see the screen there. Can you see there, Cormac, the slides?
Yeah, perfect. Bang on.
Perfect, great. And look, I think it's only 13, 14. So if anyone has any questions along the way, please unmute and jump in. Look, there's only a small, we're not a big group. So if you have any clarifications, please come along. And actually, I should just mention it's great to be presenting to TU Dublin because I did my first ever talk on 100% renewable energy in Ireland in DIT, as you were once called back in the day, back in, I think, 2009, 2010. So nice to be back coming full circle. I won't dwell too much on the introductions. So what my talk is going to focus on, I should say, is Ireland's pathway towards zero carbon energy by 2050. And I put in brackets just to kind of silo it down. It's very much the technical journey. I think the technical journey, as I'll say in my last slide, if I hopefully get that far in the 45 minutes or so, is kind of saying that I think the technical journey is actually going to be the easy part. I think the policy and social journey we're about to go on is probably going to be the much more difficult part. I suppose just to begin very, very briefly, background, I think a lot of you will be familiar with these announcements in the last few weeks and months. You know, we have incredibly ambitious targets now, which is fantastic to see in the Irish energy sector about decarbonising it. So we have a short-term target for 2030 of a 51% reduction in carbon emissions. And now we have officially a long-term target in law of being net zero by 2050. So these are monumental changes in terms of how we supply our energy needs, and they really set the backdrop for what actually is we have to do, because I think it changes the conversation from what we'd like to do to simply what has to be done. And today what I was going to do was just talk about very much for the energy sector, so I don't deal with agriculture, what kind of changes from a technical point of view do I see from the research and been involved in Wind Energy Ireland for the last 4 years, which I've just finished in. What can I see coming down the track in the next 10 years? I think this is the most important slide of the whole presentation that I'll give, and hopefully I get to cover each of these aspects, but if not, you have all the answers in this one slider. This is the best attempt I could come up with to try and shape my thoughts on how the Irish energy sector will transition over the next 10 to 30 years. And they're very much approximate numbers. They're not exact numbers, but they're approximate to just kind of explain the message, which just shows at the top what Ireland's total energy-related CO2 emissions are, which is 40 million tonnes. As I said, agriculture is not something I'll cover today, so I've just put that in to just give a sense of how important agriculture is in terms of the decarbonisation journey, in the fact that there are 20 million tonnes in agriculture compared to energy's entire 40 million tonnes. And then underneath energy, I've divided into transport, heat and electricity. As you can see, 15 million tonnes in transport, 12 in heat and 12 in electricity. This is from 2017, and I need to highlight that here because although transport and heat have stayed somewhat similar since 2017, electricity has reduced probably by another 2 million tonnes due to the rollout of more wind energy over the last couple of years. So those would probably need a bit of updating. And then I've done a further subdivision into some categories that I think are important for the solutions that they're related to. And then finally, I've given you a flavour of some of the solutions that I think will be needed for each of these sectors. So you can see, for example, the reason I've divided buildings into rural and urban is I think there's different solutions needed for urban and rural heating. So this is not a traditional way to divide a CO2 map for the energy sector, but it's my own version of how I divide it to try and then communicate what I think will be the key solutions. So for the talk today, I was just going to briefly give you some of my thoughts on what the journey will be for the electricity, heat and transport sectors based on some work I've been involved in different parts of my career to date. I think just to say as well, the 51% target that we have for our carbon emissions by 2030 because I think a lot of what I'm thinking of in this talk is that short-term target of 2030. It effectively means we need to get to 19 million tons of carbon approximately in our energy sector. So from the 40 we're at today, 51% reduction is about 19 million tons by 2030. So like that's a number I'll refer to a little bit when I talk about what I think is feasible across the electricity, heat, and transport sectors. So then just to get started with electricity. So the electricity is the 12 million ton block out of the 40 million ton block. So currently we have an ambition to get to 70% renewable electricity by 2030. That was a commitment made back in 2019 as part of the climate action plan, the first ever climate action plan published by Minister Bruton back in middle of 2019. So that the 70% renewable electricity target, and again, the most important number that matters is not the renewable electricity target, it's what it means in terms of carbon emission reductions. That should get us from about 12 million tons of carbon today down to around 3.5 million tons of carbon by 2030. So that's a wonderful step in the right direction and a huge contribution to reducing down to that 19. So we need to reduce by 21 million tons over the next 10 years. This is going to get us about 8.5 million tons of that. So a really, really good start. And because it's such a major contribution, I thought it'd be good to start here because it's probably to say it's easy to achieve is wrong, but to say it's probably the easiest to achieve out of everything is probably right. So it's certainly not easy, but it's probably the easiest of all the things we have to do across the energy sector is to get to this 70% renewable electricity target, because what it effectively requires is more of things that we're already good at. So we're really good at renewable electricity. We've built just over 4 gigawatts today. To get to 70%, we'd probably need to get to around 10 gigawatts by 2030. We need more grid capacity, which is more ability to move electricity around the country. We need to get better at integrating our electricity. And I suppose some of the metrics that are often used about how good we are at integrating electricity are things like SNSP levels. So how much electricity from wind and solar can you have at any one time on the grid? Currently, that's at 70%. We'd need to probably get to around 90% plus to get to a 70% renewable electricity system. And another one that's not often discussed, but is just as important, is we need to be better at turning off power plants in windy conditions. So right now, for example, we can't turn off power plants below a combined value of around 1,000 megawatts, because we need to keep some of them on to keep the power system stable. But by 2030, we'll need to be at least able to turn off enough power plants to get down to around 700 megawatts of what's called a minimum generation capacity. And that would be around 4 power plants operating across the entire island of Ireland to get us to that level. But again, these are things that we're already really good at. We have the DS3 program in EirGrid that is doing a lot of work in this space. It's effectively trying to do more of what we're really good at already. And we also need to build 2 interconnectors more, one to the UK, which is called Greenlink and due to come online in the middle of this decade, and one to France called the Celtic Interconnector, which EirGrid are building, and it is currently progressing really well. So this is the high level menu of what I believe are the key fixes to get us to 70% renewable electricity by 2030. I've put grid capacity in red because for me, when I see all of these and speaking to stakeholders, I think building more grid capacity across the country is probably the single biggest challenge. Historically, it's proven extremely difficult to build new wires and cables, especially overhead lines. So I think in the context of having 10 years to build a lot of new grid capacity, that's going to be a huge challenge. Just to give you a flavor of some of the numbers of what's required, these are estimates we would have done with the Wind Energy Ireland members during our time to look at how much grid capacity is left in the Republic of Ireland right now. And our best estimates, but they haven't been verified by EirGrid and ESB networks. But just to give people a flavour, we used to find that in our best estimate there was around 2 to 2,500 megawatts of grid capacity left in Ireland's onshore grid. So if we're at 4,000 megawatts today and we need to get to 10, we need to get another 6. There's only 2.5 of capacity left onshore to fill that up, and then it's full, completely full, and that's absolute max available. And then looking at offshore, which is another very, very promising area, there was a study done by EirGrid looking at what's feasible there. and it was 1.5 to 2 gigawatts is currently identified as available in Ireland's East Coast sector. So again, in terms of what we need to do, there simply wouldn't be enough grid capacity available to meet everything that we need to meet. So grid capacity is going to be a major barrier to getting us to our 70% renewable electricity target. And that's the one I just wanted to highlight in lights, because I think it's the one that's going to be the biggest challenge in the coming years. I think one thing I wanted to point to as well is this 70% renewable electricity target. There's an awful lot of nuts and bolts work required to get there. But I wanted to give you, I won't go into this in detail, but in my time in Wind Energy Ireland, we did these 4 reports that basically go into a lot of detail about what would be required on a, let's say, policy by policy level to build the onshore and offshore wind capacities we need to deliver 70% renewable electricity. So there was an onshore wind report and an offshore wind report that just looked at how those two technologies could be built out over the next decade. Then there was a saving money report that looked at how we could halve the price of wind energy in Ireland in the next decade. And then there was a saving power report that looked at all of these challenges related to the electricity grid. So if you're interested in any specific one areas of those, there's links there to those reports and webinars and press releases about those studies that I just thought would be useful to let you know are in existence if you want more detail. And I think after going through all of that, 70% feels very, very achievable. I think we have an awful lot of the groundwork done to get us there. And I suppose the reason I'm saying that is I think there could even be scope for electricity to do more by 2030, because I think we have so much of the building blocks in place to get us to 70% renewable electricity that we should think further than 70% renewable electricity. And I think that'll become more apparent when I talk about just how challenging the things we need to do in heat and transport are in comparison to what we could do in electricity are. So just to give you a flavor, if we had to go theoretically to 100% renewable electricity and to get to zero carbon emissions from the electricity sector, like I think, of course, we would need more renewable electricity, we would need more grid capacity. Instead of getting to 90% of an SNSP, we'd have to get to 100%. Instead of getting to a 700 megawatt minimum generation capacity from power plants, we'd have to get to zero. What that would mean in practice is the Ireland would effectively need to be able to have a power system that at certain moments in the year is simply operated by wind energy on its own. So that again, technical challenge, but I think we have an awful lot of the expertise available to us in Ireland to do that. And we would need additional interconnection. Sorry, we would still need the interconnection that we've planned, but we would need a few solutions beyond just interconnection to create some new forms of flexibility. And I've just highlighted those here. One of them is to make sure that the interconnectors we're building, Greenlink and Celtic, flow in the correct way. And what I mean by correct is that when it's windy, they export. When it's not windy, they import. In other words, we don't want interconnectors importing electricity when we have a lot of wind blowing in Ireland. And that's not happening fully right now. So there's some changes required to do that. And we'd need things like long duration storage for the electricity sector. And I think hydrogen power plants are some kind of hydrogen based fuel for power plants will be need us to get us to this zero CO2. So that's definitely an areas that we don't have, let's say, expertise built up in and a history of doing work in. But I think we may have to start looking to these if we need our electricity sector to deliver more than just the 70% target by 2030. So look, that's the electricity sector in 10 minutes. It's just the high level changes that I think are coming down the road in the next 10 years. More renewable electricity, more grid capacity, better at system integration, interconnectors, and if we want to go beyond the 70%, a few new innovative solutions will have to come as well as that. I just put this number in yellow just to remind you, because at the start I talked about this 51% reduction in CO2. If we do 70%, that's 8.5 million tons saved versus where we were in 2017. So we're 8.5 million tons along the journey to getting the 21 million tons. So still quite a long way to go. And this is why we may need to do more in renewable electricity. And I have this number in when I talk about heat and transport and what's possible there also. So he's next. So I'll take a few of my kind of thoughts on where we're getting to zero carbon in the heat sector. So the first thing I'll do is just talk about the heat demand. So I think the heat demand is far more important than the electricity demand in terms of understanding its characteristics. So for electricity, a unit of electricity used by a large industrial plant is the exact same as a unit of electricity used by an individual for their kettle. The electricity grid has only one type of electricity on it. And that's very different to the heat sector. The heat sector has very different types of heat depending on who's using it and how they're using it. So I suppose just to give you a flavor of the Irish heat sector, how it's broken down, about 45% is by people in their homes. About 20% is industry, or sorry, not industry, commercial buildings. So your shops, your restaurants, your small commercial premises. And then about a third is industry, large scale industry, your likes of your Auchan Illuminas, Guinness, those large industrial plants that you'd see around the place. So we have, a lot of buildings. You can see 2/3 is buildings and a third in industry. And then the other important thing about, and the reason this is important, and you'll see it when I cover it later, is how industry uses heat is very different to how buildings use heat in terms of their profile. And that for me means there's different technical solutions to these. And the other thing that's very important about heat is the geographical location around where it's used. So for example, about 25% of Ireland's heat is used in urban areas, almost a third is in suburban areas, and almost half is in, let's say, rural areas. And the reason this is really important is, urban areas are absolutely ideal for network solutions like gas grids and district heating grids. Suburban areas can be valid for networks, so they can be useful for district. They can be used. You can use district heating and gas grids in suburban areas, but not always. It depends on the characteristics of it. And rural areas are really only suitable for individual heating units. So a biomass boiler, an oil boiler, a gas boiler, or sorry, not a gas boiler unless it's packaged gas. A heat pump, an individual heat pump, can only be used in rural areas. So there's certain heat technologies that are not suitable or are suitable depending on how the heat demand is used. And again, that's very different to electricity. Like with electricity, whether it's a wind farm producing it or a solar farm or a power plant, it tends to all go onto the one grid, and we don't have to worry so much about who the end user is and what type of end user there is. Whereas this is very important for the heat sector. A lot of detail will be discussed on this in the Renewable Energy Ireland heat plan that's due to launch next week. So keep an eye on that report that's due to come out next week. That'll give a lot of these numbers. And the last thing I'll say about the heat demand is in Ireland, our heat demand is currently around 45 terawatt hours. And the reason that number can be interesting for people is our electricity demand in Ireland is around 30 terawatt hours. So we use a lot more energy on heat than we do on electricity as of today, and that could change in time as we get more electricity in the heat sector. So look, I think that's just a really interesting way to look at the heat sector. A study I used to be involved in a lot back when I was working in Aalborg University in Denmark was the Heat Roadmap Europe project. And when we looked at the building sector, so I'm just going to take that first. So the building sector being this 2/3 of Ireland's heat demand. When we looked at the building sector, generally we had three main recommendations for the building sector. No matter what country we looked at or no matter what setting we looked at, these tended to be the same three recommendations that we would find. The first recommendation was you need to do as many heat savings as is economically viable. And I think that won't come as a surprise to anybody. There's a lot of opportunities to insulate your attic, you're putting better windows, better doors, and reduce the amount of heat that your buildings need. But where I think there can be a bit of difference of opinion is it absolutely won't solve all your problems, and it is absolutely not always a good idea to continue saving heat in a building. And I'll come to that in the slide I have after this. Like we used to find that your building fleet, at a maximum, you might be able to save about 30 to 50% of the heat demand across all buildings in a country. Beyond that, it just simply became far, far too expensive to go any further. So in other words, we're never in all the work we did, it was never likely that you would reduce your heat demands to the point that you didn't need a renewable heat supply of some sort. in a best case scenario, and this is not across individual buildings, you might have some individual buildings that do more than a 30 to 50% reduction. This is about across your whole building fleet, what heat demand you're still left with. So definitely save where you can first, but it certainly won't be the panacea that solves all your problems. So because you're always going to have some form of heat demand left, then the question became, how do you best supply that heat demand? And in all the research we did, it was in urban areas, district heating networks were by far the most economic way to supply your heat demand, even in an Irish context. And I'll give a few slides on that. And in rural areas, it was heat pumps that were usually the primary way to supply sustainable heat in an economic way. That there could also be blends of other technologies on the periphery, but these were the two primary solutions that nearly always rose to the top in terms of the main sources of sustainable heat. So save as much as you can, and then in cities put in district heating networks, and in rural areas put in electric heat pumps. And of course, there might be places where these overlap with each other in those suburban areas. And you might have smaller shares of solar thermal and biomass and even some remaining gas grids in some places. These are just very much the primary sources of the solutions. Um, so I'll just take a few minutes very briefly to just explain some of the justification for these. So the first on the heat savings, and this is a very simple graph, but it just hopefully presents the concept of why heat savings can only do so much before they become very, very tricky to continue. So this graph just shows if you had the cost of saving heat on the y-axis and you had the amount of heat you save on the x-axis. What you find typically when you do an analysis of a building fleet is that at the beginning, it's really, really cheap to save heat. So there's a lot of old buildings. There's a lot of simple things you can do to save a lot of heat, like put insulation in an attic, put in some really old windows, just getting double glazing and things like that. And what you find is you save a lot of heat for very little money. But after a certain, let's say, reduction, let's say you save 30, 40% of the heat in the building, all of a sudden doing the next thing becomes much more difficult. So all of a sudden you've done the simple things like put the attic insulation in, the better windows, the better door, additional, let's say, air tightness. Now all of a sudden it's getting very tricky and you're really struggling to find cheap ways to do it. And you might have to do things like wrap the building with external insulation. And all of a sudden, your cost per unit of heat saved starts to exponentially grow. And that's happening for two reasons. One, it's because the price of what you're doing is becoming more and more expensive. But the other reason it's happening is your building is actually getting better and better. So the amount of heat that that building is using is now quite low. So by doing an extra measure, you're not getting a really big chunk of heat that you're saving. And so what we would have typically found in most countries where we worked with building experts and did this type of analysis for a building fleet was the price of continuing to do heat savings would take off on an exponential curve at a certain point along the heat saving trajectory. And what would typically happen then is it actually became much cheaper to supply zero carbon heat with district heating or a heat pump than it did to continue adding more and more heat saving measures. In other words, getting to zero carbon was cheaper by supplying zero carbon heat than it was trying to remove the heat demand altogether. And that typically happened around a reduction across the building fleet of in a 30 to 50%. I haven't seen yet a building fleet analysis that says it's better for the entire set of buildings in a country that I was involved in any that said you go beyond a 50% reduction. It just the cost became extremely, extremely high. And that was the logic behind you still need some form of zero carbon heat supply. So then if you just take this right back to Ireland, if we look at, well, what could Ireland do to supply sustainable heat in the future? It's exactly the same recommendations that we found when we did a lot of other European countries. So district heating in the cities and electric heat pumps in the countryside. And of course, the first question I always get asked is, well, is district heating viable in Ireland? Because people think that Ireland is too warm, ironically, for district heating. It's about the only conversation I ever have where people think Ireland is too warm. And I can assure you it's not too warm for district heating. So we developed this heat atlas in the Irish District Energy Association, which I'm chairperson of, and we looked at how much of Ireland's heat demand is in areas with heat densities high enough to justify district heating. And these heat densities in this table here, these are the heat densities that Scandinavian countries use to say if an area is suitable or not suitable for district heating. So in Denmark right now, you would not find a set of buildings in an area with a heat density above 120 terajoules per kilometer square that are not connected to a district heating system. That would be considered absolutely perfect. Anything with 120 terajoules a kilometer squared of a heat density or above is absolutely economically viable for a district heating network to be put in place rather than individual heating solutions. And when we did the heat atlas, we found that 35% of Ireland's heat demand is in areas with these heat densities, with those areas are above. We even have 8% of our heat demand in areas with over 300 terajoules per kilometer squared of a heat density, which just would be like beyond perfect for a district heating system. You would absolutely never find something like that in Sweden or Denmark that isn't converted to district heating with those sort of heat densities. So I suppose if people want to go to the website here, you can check out the heat atlas for yourselves. It's very interactive. You can zoom in and zoom out, but that kind of just gives you a flavor that the recommendations we used to find for other countries, I think, are absolutely valid in an Irish context as well. And then the good news is that countries have gone there before us and shown how this can be done. I often get asked that people almost assume that in Denmark and Sweden it was the Vikings that put in district heating. They're like, oh, it's been around forever. Well, it hasn't. It certainly hasn't been around forever. District heating started in Scandinavia in the 60s and 70s. In Sweden, which was one of the earliest, it was in the 60s. In Denmark, it was in the 70s. And what they did was they rolled out district heating in their cities, steady but surely over a long 30, 40-year period. So you can see this is the graph for Sweden of how much of the percentage of their heat demand has converted to district heating in the last 40 or 50 years. And it's effectively a 1% per year rollout constantly for the last 30, 40 years. So this is not, like you can see even in the early 2000s, district heating was being put into buildings for the first time. So it's not a case of it's been around for forever in Scandinavia. They've steadily but surely built it up. And this is where I think Ireland can learn from this. We can say, well, how do they do this, and start steadily rolling out district heating in Ireland also. And what makes this so attractive is district heating is a really cost-effective and proven way to implement renewable heat in the heating sector. So if you look at the share of renewable heat in different EU countries, all of the countries with the highest renewable heat share have district heating systems. This is the green is the district heating system here. And as you can see, Sweden that I just showed you, which has one of the highest district heating shares in Europe, is actually the highest when it comes to the share of renewable heat in Europe. And I think there's easy wins here for Ireland because this is not about trying to invent things first. Like in the electricity sector, we have to be world leaders. This is very much about copying and pasting proven solutions. So like Sweden has a renewable heat share of over 65%. We're at 6%. So we have so many things we can just copy and paste from all these other countries to get us up this curve very, very rapidly. And district heating is certainly one of those in my opinion. The other thing on the heat sector that I just very briefly will mention, but I won't spend much time on it, is the heat pump side. I think the reason I'm not going to spend much time on this is because I think there's huge support for this already and it's happening, and there's a lot of political will to make this happen. So in the Climate Action Plan in 2019, there was a target to get 600,000 heat pumps in Ireland by 2030. So that's exactly in line with what we would have recommended is a really good idea in the heat plan work, heat roadmap Europe work we would have been involved in. The only thing I would add to that that's really important is that these individual heat pumps should be prioritized for rural and suburban buildings. In other words, those urban areas is where we need large scale heat pumps, not individual heat pumps. So that might be a nuance, but something maybe very important in terms of how we roll this out, because we don't want to lock ourselves into asking somebody to switch to a heat pump in 2028 and then coming back and asking them to switch to district heating in 2035. So just so we don't lock ourselves into stranded assets down the road, I would argue that the best place to put these 600,000 heat pumps is in rural, as many rural buildings as we can, especially replacing oil boilers. And I think the really great thing about heat pumps that I just said I'd make one quick reflection on is not only do they let's say, give us a huge efficiency gain, which I'm sure many of you are familiar with, but effectively they make the homeowner zero carbon. So of course, heat pumps are not always zero carbon depending on your supply of electricity, but they do move the responsibility of becoming zero carbon from the homeowner to the electricity grid effectively, which is a really important benefit because it means you as an individual have done your part of decarbonizing your home, and it's then over to the electricity grid to decarbonize to finish that circle. And as I mentioned in the first section, I think we're really doing very well in electricity. So I can see this being a really good outcome for Ireland. So I purposely haven't spent a lot of time reflecting on heat pumps because I think it's just such a well-known area and there's so much momentum building up here. Whereas the district heating, I think there was a lot less momentum and a lot less discussion happening. So I spent most of my time on that part. So overall for buildings, it's heat savings, district heating in the cities, and heat pumps in the rural areas. I won't spend too much time on this either, but I just wanted to say I think it's a really critical area. It goes back to my CO2 map at the start. You might remember, or if you even just look at it afterwards, heat demand was 12 million tons overall. 8 million tons was buildings, 4 million tons was industry. So industry is an absolutely critical part of the decarbonisation story for heating. But the one thing I just wanted to kind of, suppose, reflect on in the heat for industry was that temperature is probably the most critical thing when it comes to the way that industry uses its heat. So if you looked at buildings, geography and location was critical. Was it a heat network or was it an individual heating solution? With industry, there's a very, very large bandwidth of temperature profiles required for heating in industry. Everything from less than 100 degrees Celsius heat is needed all the way up to above 200 to 400 degrees Celsius heat. Even above 400 degrees Celsius is needed sometimes. And this temperature level has a huge influence in terms of what solution is viable for you to decarbonize your industrial heat activity. Because once you go to above, 200 degrees Celsius, your number of solutions decreases dramatically because typically heat pumps are not suitable for above 150 to 200 degrees Celsius. So it kind of rules out certain solutions that are viable depending on the temperature level you're at. And in that Renewable Energy Ireland heat plan that's launching next week, there is some information about the breakdown of heat demand in Ireland based on temperature level. So keep an eye on that. It's a really interesting piece of analysis that then tries to look at what kind of solutions could we use for these type of temperature levels in Ireland. So I won't go into that in detail, but I just didn't want to leave it all together because it's a really interesting piece of analysis, but it's in the REI heat plan. You'll hopefully get a bit more information about the type of mix that could be used for the industrial heat demand. The last thing I just wanted to say was, with all of these solutions, the district heating, the heat savings, the heat pumps, and even the solutions for industrial heat demand, by 2030, I find it hard to imagine that we'll, even with the most ambitious plans we could possibly achieve, I think we'll only reduce our heat CO2 related emissions by about 6 to 7 million tons. So that just means on top of the 8.5 that we had in electricity earlier, plus the 6 to 7 in heat, we're about 13, 14, 15 million tons along the journey that we need to get to by 2030 of 21. So there's still a big gap for transport to fill, which will be the last thing I talk about. So it just gives you a sense of the scale of the challenge. So next week, when you see the REI heat plan, if we did everything in that, I think it would still only get us to 6 or 7 million tons of a reduction, which is still a huge, huge challenge. And then finally, with transport, I'm just keeping an eye on the clock, so I probably will. I won't spend as much time as this as I did on heat. But this is my breakdown between the transport CO2 emissions of 50 million tons, so private cars, heavy duty, aviation, and other. And I've purposely done it like this, as you I'm sure have guessed, because private cars, of course, have electric vehicles, whereas the other applications are going to struggle to use electricity, at least directly anyway. So I'll talk very briefly about what I think are really promising solutions for transport. The first being electric vehicles. And you can see from the layout of this slide, it's very similar to my slide on heat pumps because I think electric vehicles are very, very well recognized as a promising solution for 2030 and for Ireland's decarbonisation journey. So again, I'm not spending long on it because I think the narrative is so well established and the ambition is so well established for electric cars. The 2019 Climate Action Plan is aiming to get 1 million electric cars on Ireland's roads by 2030. Like that's probably as ambitious as we possibly can be. And just like heat pumps are more efficient than boilers, one thing that's really great about electric vehicles is not just that they're zero carbon, but they're also much more efficient. So an electric car is about 4 times more efficient than a internal combustion engine. So we get really great gains in terms of energy efficiency, as well as getting our carbon footprint down quite a lot as well by moving to clean electricity rather than fuel. And I suppose that's the obvious. I don't need much more to maybe reflect on it. I think it's a really great thing that we have so much support for electric vehicles. I think out of electric vehicles, this million EVs I think will save about 2 to 3 million tons out of the carbon footprint that transport has. And I suppose this is why I was really just adding up the numbers as I went along, because what we're doing today across electricity, what we could maximum do in heat, and what we're going to do with electric vehicles, if you add all of those up together, you're probably getting somewhere in the region of 17, 18 million tons, but we need to get 21 million tons. So I suppose I'm sure it won't come as any surprise to anybody on this talk that what we're doing is incredibly ambitious, but it's still not going to be enough. It simply won't be enough to meet what we want to achieve. So we have to go beyond extremely ambitious by 2030. So the challenge is absolutely immense. And it is immense what has to be done in a decade. So I suppose my other part of the transport story was, well, could we do more in transport? I've already given you a flavor of what we could do in electricity. I think there could be more in electricity that could be achieved, but could we do more in transport? And I suppose this is a very brief reflection on how can we go into those hard to decarbonize areas of the transport sector that cannot use batteries. And this is an area that I think is really exciting, and I think Ireland could absolutely try to be a world leader in this. And this is using our clean electricity to produce fuel. So for places that cannot use a battery and they need a high energy dense application, um, like trucks or ships or airplanes, we can use our clean electricity, wind and solar, to effectively produce a fuel. And this is done by trying to replicate oil and gas. So many of you might have heard the term hydrocarbon used to describe oil and gas. So this is just a molecule of diesel I have in the top right, where you can see diesel is effectively fuel made up of carbon and hydrogen molecules. So if we can fake this or replicate this, is probably a better word, using renewables, we can start to produce clean fuels for these applications. And the way that we can do that is we can take some carbon from somewhere and we can combine that with hydrogen that is produced from renewable electricity to create fuel. And that fuel in makeup can look very similar to all the fossil fuels that we're used to having around us every day already. And this is effectively a way to start to provide renewable alternatives to the likes of ships and airplanes that can't rely on batteries, that we need to get some kind of high energy dense fuel application for. So for example, methanol is a very common replacement for petrol, and DME, dimethyl ether, is a very common replacement for diesel. And if you want to produce 1 terawatt hour of methanol or DME, you need about 1.15 terawatt hours of hydrogen, and you can produce that using clean electricity. And you need about 250,000 tons of carbon that you sequester from somewhere. And if you do that, you can then create fuels from clean electricity. And there's a lot more detail on this in a paper I wrote a few years back. This expanded diagram just gives you a flavor of where the different forms of carbon and hydrogen can come from. But what makes this so exciting then is you can start to go beyond electric vehicles in the transport sector and start to use clean electricity to produce fuels. And I think there's the other thing just to say here, by the way, what could happen here is if we can't capture the carbon, we could try and find ways to use the hydrogen directly. But what makes that a bit more challenging is the vehicles are not readily available to do that just yet. So we don't have like a hydrogen plane or a hydrogen ship at the moment, but that could emerge in the coming years. But this could be a way for transport to do more than just the electric vehicles, which is the primary solution that we have for transport right now. And I think I'll leave the rest of transport. You can look through my other 2 or 3 slides on transport for if you want afterwards. I think the last thing I'll just reflect on is what brings this all together. So what I've described there obviously is monumental changes across electricity, heat, and transport. But one thing worth checking out is this website, smartenergysystem.eu. There's a really nice video of about 15 minutes that describes the concept of what does the world look like when we do all of these changes across all of these 3 sectors and how they work together. And what makes this really interesting is this smart energy system concept really makes you see how all of this can work together in a way that's very different to today. So what you see in this graph is how we supply electricity, how we supply energy. So in a zero carbon world, it'll be almost all bioenergy and wind and solar. So fossil fuels are completely gone. And then you can see different ways that, obviously when we lose fossil fuels, we lose energy storage, we lose flexibility. We can't tell the wind when to turn off and we can't tell the solar when to come on. But by introducing these new technologies like EVs in the transport sector, electrofuels in the transport sector, heat pumps in the heat sector, what we start to do is we connect wind and solar to new forms of energy storage. So we connect via heat pumps to thermal storage, we connect from electrofuels to fuel storage, and we connect to electric vehicles to batteries. And this is the type of modeling we would have done in Energy Plan in Albury University, is that the reason that we can start to then rely on zero carbon energy systems that are built around wind and solar is that we have all of this flexibility within the energy system to manage the weather effectively. So we lose fossil fuels, which means we lose a lot of energy storage, but we compensate for that by creating an awful lot of energy storage and flexibility inside the energy sector. And this is what used to be really interesting about modeling these things, is how all of the lights could stay on and all the homes stay heated by getting the right amount of energy storage inside in the energy system. And I'm just conscious of time, so I suppose I'll just wrap up by saying, Green Plan Ireland was a study I did a few years back, which modeled all of these things in a lot more detail. So if you're interested, you can go to the website here and read about Green Plan Ireland a bit more, which will go into a lot more detailed modeling. And the last study I launched in Wind Energy Ireland before I finished up was a study we did with UCC and Marai, which showed how a zero carbon Ireland could look like in a lot more detail than I've described today, which is very much just the high level messages. And as you can see, a zero carbon Ireland in 2050 is almost all wind and solar and bioenergy, as we used to find in the smart energy systems work that we did in all of our university in the past. So I think I'll leave it there, and hopefully you got a flavor of what the journey to zero carbon looks like from a technical perspective, at least. I think I'll finish by just saying what I started with, which was, I think the technical journey is going to be the easy part. I think the tough part is going to be the political and social changes that have to go on beyond all of these technologies. But that's a whole other presentation, but definitely an area that would be very interesting to have more research done on in the future. So happy to take any questions, Cormac, that people have, and hopefully it was useful.
No, I can't thank you enough, David, for that presentation. I think it gives a wonderful oversight to what's happening and how we are going to have to change every aspect of our lives in many respects. So I'm happy, guys, to open it out to the floor for any questions. I have some questions, but I'm more than happy if anyone else has some burning questions first to ask David.
You'll get the short straw, Cormac.
Greg, you have a question there.
Thank you very much. Fascinating presentation. What I'm wondering is, given we have made fair progress, or we've made some progress on things like wind provision of wind generated electricity, so that we're at the point where on a busy, autumn or spring night, we're close to 100% of demand. And a bit more than half, probably, or potentially half on a stormy day. But given that